Hello, in this lecture we will find the value of DE. In the drawing we have triangle ABC. We know that AC equals to 2 units, BC equals to 8 units, and we also know that DE is parallel to AB, and G is the centroid of the triangle. The centroid of any triangle is the point where the medians of the triangle are intersects. Okay, and we also know that the size of DE is a natural number, and we want to find that size of DE. Okay, so we actually have a rule that in any triangle, if we have triangle ABC, and in triangle ABC we know that the median to BC is AD, actually the median AD divides BC to two equal parts. That is to say, BD equals to DC, and we also know that G is the centroid of this triangle ABC. Then actually the centroid G of this triangle ABC divides the median AD in a ratio that equals to 2 to 1. So if AG equals to 2, then GD will be equal to 1. Or we can also say that if AG equals to 2y, then GD will be equal to y. Okay, if AG equals to 2y, then GD will be equal to y. So actually we know that G is the centroid of triangle ABC. Therefore, according to the rule that I stated, the centroid divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2x, then GE will be equal, then GF will be equal to x. Why? Because the centroid G divides the median GF in a ratio that equals to 2 to 1. So if CG is equal to 2x, then GF will be equal to x. Okay? So if CG equals to 2x, then GF will be equal to X. Okay, and we also have the second rule that states that if we have triangle ABC, and we know that DE is parallel to BC. If we know that DE is parallel to BC, then according to the rule AD over DB, AD over DB will be equal to AE over EC. I will repeat again on the rule that states that if we, in triangle ABC, that can be any triangle, we know that DE is parallel to BC, then AD over DB will be equal to AE over EC. So we actually can implement that rule in our drawing, because in our drawing we know that DE is parallel to AB. DE is parallel in triangle ABC. We know that DE is parallel to AB. Okay, DE is parallel to AB. Therefore, according to that rule, according to this rule, we can say that CD over AD or CD over AD or CD over DA equals to CG over GF. CG over GF. Again, we relate to triangle ACF. So in triangle ACF, we know that DG is parallel to AF. Okay, in triangle ACF, we know that DG is parallel to AF. I will repeat again. In triangle ACF, we know that DG is parallel to AF. So according to the rule that I stated, CD over DA will be equal to CG over GF. Okay? Again, in triangle ACF, this triangle, we know that DG is parallel to AF. Therefore, according to the rule that I stated, CD over CA will be equal to CG over GF. Okay, but we know that CG equals to 2x and GF equals to x. Okay, we know that CG equals to 2x and GF equals to x. So 2x over x is 2. So in total we got that CD over CA equals to 2. Okay, we know that CD over CA equals to 2, or CD equals to 2 times CA. CD equals to 2 times CA, so if CD equals to 2y according to our definition, if CD equals to 2y according to our definition, then we can substitute CD by 2y in this equality, and we will get that 2y equals to 2 times CA. We will divide this equality by 2, and we will get that CA equals to y. So we found out that if CD equals to 2y, then dA equals to y. Again, we have the rule that states that CD over dA, CD over dA equals to CG over GF. According to the rule that we stated in triangle ACF, we know that in triangle ACF, we know that DG is parallel to AF. Therefore, according to the rule that I stated, CD over AD equals to CG over GF. Again, CD over DA equals to CG over GF. Okay? So, here we will get that CD equals to 2 times DA. And if CD equals to 2y, then we will substitute CD in this equality by 2y, and we will get that 2y equals to 2 times dA. We will divide this equality by 2, and we will get that dA equals to y. dA equals to y, so here dA equals to y. So if CD equals to 2y, then dA equals to y. Okay? And because of the fact that DE is parallel to AB, we have a rule that states that corresponding angles between parallel lines are equal to each other. So DE is parallel to AB, therefore the corresponding angles, that is to say those two angles, will be also equal to each other. So if angle CAB is alpha, then angle CDG will be also equal to alpha. And the same rule applies on the other side of the triangle. We know that CD is parallel to AB, and therefore the corresponding angles, that is to say angle CBA, will be equal to angle CED. So if angle CBA equals to beta, then angle CED will be also equal to beta. Okay? So in the next step we will focus on triangles ACB, triangle ACB, and triangle CDE. Those two triangles, on those two triangles, we know that angle CDE equals to angle CAB, and both those two angles are equal to alpha. Okay, and we also know that angle CED, this angle CED is equal to angle CBA, and both those two angles are equal to beta. Okay, so we have in those two triangles two angles that are equal to each other, and the third angle, that is to say this angle, I will call it angle C, is a common angle because it belongs to both triangles. So angle C equals to angle C, because actually it is a common angle. It belongs to both triangles. So we actually proved that all the angles of triangle ACB are equal to all the angles of triangle CDE. Therefore, triangle ACB is similar to triangle ACB. Triangle ACB is similar to triangle CDE. That is the sign of similar. Triangle ACB is similar to triangle CDE according to angle rule. According to angle rule. So what is the angle rule? If you prove that all the angles of one triangle are equal to all the angles of the other triangle, then those two triangles are similar to each other according to angle rule similarity. Okay? So from the fact that those two triangles are similar to each other, we can conclude that CD over AC is equal to DE over AB. Again, we proved that the small triangle CDE is similar to the big triangle ABC. Therefore, according to the rule of similarity between triangles, we can conclude that CD over AC equals to DE over AB. So, what is the value of CD? CD equals to 2y. CD equals to 2y. And what is the value of AC? AC equals to 2y plus y. 2y plus y, it equals to DE over AB. So in total, we got that 2y over 3y equals to DE over AD, or 2y over 3y is 2 over 3 equals to DE over AB. Okay, 2 over 3 is equals to DE over AB. We will multiply this equality by AB and we will get that DE is equal to 2 over 3 times AB. So we actually found out that DE equals to 2 over 3 times AB, and we also have another rule that states that in any triangle if we have triangle ABC that can be any triangle, and we know that the size of AB is A units, the size of side AC is B units, and the size of side BC of triangle ABC is C units, then the size of BC that it equals to C units will be less than the sum of the other two sides, that is actually A plus B, and the size of BC that is actually C will be greater than the difference between those two sides, that is to say, it will be greater than the absolute value of A minus B. Okay? So in any triangle, the size of one side of the triangle will be always less than the sum of the other two sides, and it will be always more than the side of a triangle will be greater than the difference of the other two sides. That is to say, the size of C of triangle ABC, or the size of side BC that is actually C units, will be greater than the difference between the two other sides, that is actually A minus B. So the size of a side of a triangle will always be less than the sum of the other two sides, that is to say, C is less than A plus B, and it will be always greater than the difference between the other two sides, that is to say, C will be always greater than A minus B, or the absolute value of A minus B. Okay, so we can implement this rule in our triangle ABC. We can say that the size AB of triangle ABC will be less than the size of AC plus BC, so the size of AB will be less than the sum of the other two sides, that is to say, AB will be less than AC plus BC. AB is less than AC plus BC, and it will be greater than the difference of the other two sides, that is to say, it will be greater than the absolute value of AC minus BC. Okay, actually this equality or this formula is the implementation of this rule in our triangle ABC. Okay, we relate to triangle ABC. In triangle ABC, the size of side AB is less than the sum of the other two sides of the triangle, and AB is greater than the difference between the other two sides of the triangle ABC. Okay? AB is less than the sum of the other two sides of the triangle ABC, and it is greater than the difference of the other two sides of the triangle ABC. But we know that AC equals to 2 units and BC equals to 8 units, so actually AC plus BC is 2 plus 8. And it is greater than 2 minus 8. So we got that AB is less than 10 and greater than 6. AB is less than 10 and it is greater than the absolute value of minus 6 is 6, because the absolute value of any number is the distance from 0. The distance of the number from the 0 and the distance of minus 6 from the 0 is 6 units. So we found out that AB equals to AB is greater than 6 and is less than 10. But we have already found out that DE equals to 2/3 AB. We have already found out that DE equals to 2/3 AB. So if we multiply this equality by 2/3, we will get that 2/3 AB is less than 2/3 times 10, and it is greater than 2/3 times 6. So 2/3 AB is greater than 2 times 10 is 20, and 20 over 3 is 6.66. And it is greater than 2 times 6 is 12, and 12 over 3 is 4. And what is 2/3 AB? 2/3 AB is actually equals to DE. So we can substitute 2/3 AB in this formula by DE, because DE equals to 2/3 AB. And we will get that DE is less than 6.66 and it is greater than 4. Okay, so we found out that DE is greater than 4 and it is less than 6.66. But we also know it is given us in the question that DE is a natural number. DE belongs to the natural numbers. So the natural numbers that are greater than 4 and less than 60, less than 6.66 is actually 5 and 6. So DE can be equal to either to 5 or to 6, because of the fact that DE is a natural number. So DE can be equal to either to 5 or to 6. So the size of DE is either 5 units or 6 units. Okay, that is the answer to the question. So now I will summarize the lecture. Actually, we wanted to find out the value of DE. We know that AC equals to 2 units, BC equals to 8 units, and we also know that DE is parallel to AB, and we know that DE is a natural number, and we also know that point G, this point, is the centroid of triangle ABC. What is the centroid of triangle, of any triangle? The centroid is a point where the medians of the triangle are intersect with each other. Okay? And we know that in any triangle, if we have triangle ABC, and we know that G is the centroid of triangle ABC, so, and AD is the median of triangle ABC, that is to say, it divides side BC to 2 equal parts, that is to say, BD equals to DC. It bisects side BC. Then, actually, the centroid G of triangle ABC divides the median AD in a ratio that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 units. Or you can also say that if AG equals to 2y, then GD will be equal to y. Or in other words, AG is twice the size of GD. Okay, so if AG equals to 2y, then GD equals to y. Okay, so we know that in our triangle ABC, the big triangle, G is the centroid of triangle ABC. Therefore, the centroid G divides the median CF. The centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG is 2, then GF is 1. Or you can also say that if CG equals to 2x, then GF equals to x. Or in other words, CG is twice large as GF. The size of CG is twice the size of GF. So if CG equals to 2x, GF equals to x. Okay, so if CG equals to 2x, then GF equals to x, because G is the centroid of triangle ABC that divides the median CF in a ratio that equals to 2 to 1. Okay, and we have another rule that actually in any triangle ABC can be any triangle. If DE is parallel to BC, then AD over DB equals to AE over AC. Again, if in triangle ABC that can be any triangle, we know that DE is parallel to BC, then AD over DB equals to AE over EC. So we actually can implement this rule in our triangle. We will implement the rule in triangle ACF. In triangle ACF, we know that DG is parallel to AF. Again, in triangle ACF, this triangle, we know that DG is parallel to AF. Therefore, according to the rule that is stated, CD over AD will be equal to CG over GF. Okay? According to the rule that is stated, if you have a triangle two sides that are parallel to each other, that is to say DG is parallel to AF, then CD over DA will be equal to CG over GF. CD, we know that in triangle ACF, DG is parallel to AF. Therefore, according to the rule that I stated, CD over DA equals to CG over GF. Okay, but we know that CG equals to 2x and GF equals to x. CG equals to 2x and GF equals to x. So we substituted CG by 2x and GF by x, and we got that CD over DA equals to 2. CD over DA equals to 2. Okay, or CD is 2 times AD. CD is 2 times AD. So actually, here, if CD equals to 2y, then AD will be equal to y, because CD is twice as large as AD. So if CD equals to 2y, then AD will be equal to y. Okay, so if CD equals to 2y, CD equals to 2y, we will substitute CD by 2y in this equality, and we will get that after we divide this equality by 2, we will get that AD equals to y. So if CD equals to 2y, then AD equals to y. Okay, and then we have another rule that states that parallel corresponding angles between parallel lines are equal to each other. We know that DE is parallel to AB. It is given us in the question. Therefore, the corresponding angles will be also equal to each other. That is to say, angle CAB will be equal to angle CDA. So if angle CAB equals to alpha, then angle CDA will be also equal to alpha. And because of the fact that DE is parallel to AB, then those two corresponding angles will be also equal to each other. So if angle CED is beta, then angle CBA will be also equal to beta, according to the rule that corresponding angles between parallel lines are equal to each other. Those two lines are parallel to each other. Therefore, the corresponding angles will be also equal to each other. Those two corresponding angles will be equal to each other, and those two corresponding angles will be also equal to each other, according to the rule that corresponding angles between parallel lines are equal to each other. Okay? Then we focused on the big triangle, triangle ABC, and on triangle, the small triangle, triangle CDE. We know that in those two triangles, those two angles are equal to each other. Both of them are equal to alpha. according to the rule that corresponding angles between parallel lines are equal to each other. So angle CDE is equal to angle CAB, that equals to alpha. We also know that those two angles are also equal to each other. Both of them are equal to beta. So angle CED is equal to angle CBA, both of them are equal to beta. And the third angle, the third angle, angle C, is a common angle. It belongs to both triangles. So we can write down that angle C equals to angle C. It's a common angle. So in this way we actually proved that all the angles of triangle ACB are equal to all the angles of triangle CDE. Therefore, we proved that triangle ACB is similar to triangle CDE according to angle similarity rule. If you prove that all the angles in one triangle are equal to all the angles of the other triangle, then we actually proved that those two triangles are similar to each other according to angle similarity rule. So we proved that all the angles of triangle ACB are equal to all the angles of triangle EDC. Therefore, we proved that those two triangles are similar to each other. And from the fact that those two triangles are similar to each other, triangle ACB, the big triangle, is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Again, CD in the small triangle over AC, the side of the big triangle, will be equal to DE over AB. Okay, according to the rule that if you have two triangles that are similar to each other, then the following relationship exists between their sides. That is to say, CD over AC equals to DE over AB. But what is the value of CD? CD equals to 2y. CD equals to 2y. And what is the value of AC? AC equals to 2y plus y. AC equals to 2y plus y. So we got that 2y over 3y is 2 over 3, y will get cancelled. So we got that 2 over 3 equals to DE over AB. We multiplied this equality by AB and we got that DE equals to 2/3 times AB. So we know that DE equals to 2 over 3 times AB. And we also know that in any triangle, if we have triangle ABC that can be any triangle, if we know that the side of AB is A units, the side of AC is B units, and the side of BC is C units, then the side of one side of any triangle is always smaller than the sum of the other two sides. That is to say, C is less than A plus B from the other side, and from one side, but in the other side, C is greater than the difference between the other two sides. C is greater than A minus B. Again, so C is less than A plus B, and C is greater than A minus B, or the absolute value of A plus B. Okay, so we implemented this rule in our triangle ABC. We related to the side AB. The side AB of triangle ABC will be less than the sum of the other two sides. That is to say, AB is smaller than AC plus BC, and AB will be greater than the difference between the other two sides of the triangle. That is to say, it is greater than AC minus BC. We know that AC equals to 2 units and BC equals to 8 units, so AB will be greater than 2 minus 8 is minus 6, and the absolute value of minus 6 is 6, and 2 plus 8 is 8, so AB is greater than 6 and less than 10. But we have already found out that DE equals to 2 over 3 times AB. So we multiplied this formula by 2 over 3, and we got that 2 over 3 times AB is greater than 2 over 3 times 6 and is less than 2 over 3 times 10. 2 over 3 times 6 is 4, and 2 over 3 times 10 is 6.66. So we found out that DE is greater than 4 and is less than 6.66. But we also know it is given us in the question that DE is a natural number. It belongs to the natural numbers. So which natural numbers we have that are greater than 4 and there are that are less than 6.66? The natural numbers that we have between 4 and 6.66 is 5 and 6. So we found out that the size of DE, the size of this line segment DE, is either 5 units or 6 units. Again, the size of DE is either 5 units or 6 units. Okay, so that is the answer to the question. Thank you very much.